Hello maths fans and welcome to my channel. So for anyone that doesn't know, this thing basically came about thanks to my grade 10 class. They were desperate for me to start a YouTube channel talking about maths. I set them the challenge: if they could get 100 signatures on a petition, then I would do it. And they actually managed to get 108 signatures in the course of about less than half a day. So I'm a man of my word, so I am doing it, creating a YouTube channel to talk about interesting maths and interesting things that I notice around the world to do with maths. And I thought I would start with quite a simple problem, but one that maybe has a slightly surprising solution. Okay, imagine taking a piece of rope and wrapping it the whole way around the entire globe. So you start somewhere on the earth and you start walking and you lay your rope out along the ground and you lay it out all the way around the world, and then when you get back to where you started again, you tie a knot. Now you'd need a pretty long piece of rope to do that, but you can imagine in your head that that was possible. And now imagine that you and some friends go and you position your friends at various points around the world. I'm just going to draw 4 friends, but obviously you'd need a few more. Few billion friends maybe. And you say, okay, I'm going to take my rope that goes all the way around the world, I'm going to untie the knot, and I'm going to get me and all my friends to pick it up. So we're going to hold it a meter off the ground, so sort of about waist level, I guess. Maybe a bit higher than that. A meter off the ground all the way around the globe. So it's now 1 meter off the ground. Now obviously, to do that we would need more rope, right? We would need to make our rope longer. And the question, this problem is, well, how much more rope would you need? Have a think about that for a second. How much do you think it would be? Would it be a lot? Not very much? You might think you would need quite a lot. I mean, the world is very big. We're holding it a meter off the ground absolutely everywhere. I mean, I'm holding it a meter off the ground here, and so's my friend there and there and there, all the way around the globe. And we've all made the rope a bit longer by picking it up, because it's now got to go all the way around, not just the globe, but the globe plus another meter. So the answer might surprise you. The answer is that we need roughly a little bit more than 6 meters more rope to go 1 meter off the ground the whole way around the world. Obviously we started with a pretty long rope, and it's still going to be pretty long, but it's only going to be 6 meters longer, roughly. It's about 6.3 meters longer than it would have been before. So let's see if we can understand where this comes from. Now, in order to solve this problem, we need to work with the radius of the Earth, but we don't know what the radius of the Earth is, so we'll just call it RE for the purposes of this. And you might know that there's a formula for the circumference of a circle. It's quite easy to work out. The circumference of a circle is equal to 2 times pi times the radius of the circle. So the circumference of the Earth, that would be the length of our original rope, is 2 times pi times the radius of the Earth. That would be the length of the original rope. Well, original. Now that we've picked it up by a meter everywhere, we can see that, well, the radius, that's the radius of the Earth, but now the radius is 1 meter more. So it's radius of the Earth plus 1 meter. So the circumference of our new rope is going to be 2 times pi times the radius of the Earth plus 1 meter. Well, how much more is this than this? Well, if we multiply it out, we can see it's 2 times pi times the radius of the Earth plus 2 times pi. So that there is the length of the original rope, and this is the extra part, the extra length needed. And as you know, pi is approximately equal to 3.14, so 2 pi is approximately equal to 6.28 meters. Interesting, huh? And maybe a bit surprising. You might have thought the answer was a few thousand meters needed, but no. just over 6. Well, I hope you enjoyed my first attempt at a maths themed YouTube video. If you liked it, don't forget to hit like, hit subscribe, tell all your friends. I'm going to try and make videos reasonably regularly whenever I can think of anything interesting to make a video on. If there's anything you particularly want to hear about, any particular part of high school maths that you're interested in, or you want to see some interesting problems or interesting applications of, just pop it in the comments and I'll see what I can do. Let's make this thing a success.